We're now ready to look at graphing the cosine function, and you can see from your picture here that the graph of a cosine function looks very, very similar to a sine function in that it is a periodic function. And so if we just take a quick peek at the graph, we can see that the amplitude is going to have a similar characteristic, that from the middle of the graph, the amplitude is 1. Our graph will finish a cycle in 2 pi radians. That's equivalent to 360 degrees. We can plug any number we want in place of theta. We don't have any restriction in the cosine function or the sine function on what we can plug in for an angle. We will have the restrictions on all the other trig functions, by the way. And then the range is same as sine, as low as -1 and as high as 1 for the y-coordinate. Okay, now I have a picture here of the graph, but let's look at where this came from again, because if we're trying to sketch this wave without it being given to us, we want to think of what our strategy is going to end up being. So we know that if we have the unit circle, that the x-coordinate on the unit circle corresponds with the cosine of the angle. We have the cosine of the angle and then the sine of the angle. And remember, this is our unit circle, so this will be 1 unit away from the origin. And so at the beginning, at an angle of 0, putting our angle in standard position and starting at 0, the x-coordinate is 1, so we would have a 1. And then we can see what happens to the x-coordinate. The x-coordinate, as our angle gets closer to pi over 2 radians, or closer to 90 degrees, our x-coordinate keeps getting tinier and gets up to 0 when we're at pi over 2. Now our x-coordinate goes negative. It's getting closer and closer to to -1. The y-coordinate's getting closer to 0, but our x-coordinate's getting closer. It was at 0 here, and it's getting closer to -1. And then our x-coordinate, as we continue to rotate around to 3 pi over 2, the x-coordinate's -1, then it keeps getting closer to 0 at 3 pi over 2. And then as we rotate back around, the x-coordinate gets positive, and it goes back up to a 1. And then the cycle continues. If we actually took this graph and had it go back to here, back to -pi over 2, because if we rotate in this direction downward, we can see that our x-coordinate down here at -pi over 2 would be 0. And if I look at this, it looks like a sine function. So there is definitely a relationship between sine and cosine. Our sine function will start at the origin. Our cosine function will actually be at one of its highs at an x value of 0, or a theta value of 0. Okay, so let's look at what happens when we do the changes to our coefficients in front. And we can see that exactly the same thing happens with cosine as sine, that this value in front affects our amplitude, so the amplitude is the absolute value of A. This little b will control how many cycles we see between 0 and 2 pi. So if this number is a 1, as it was the case up above, you would have 1 cycle between 0 and 2 pi. If this number is a 2, there would be 2 cycles between 0 and 2 pi, etc. And same exact idea for the period. The period, or the length of a wave, will be determined by taking 2 pi divided by the coefficient b. And if we were in degrees, it would be the same idea with the substituting in place of 2 pi. We would have 360 degrees in that top. But again, you will be graphing in radians. So if I want to graph this function, let me switch to this piece of paper so that we have a blank here. If we want to graph this function over the interval from 0 to 4, we have some things we want to find. We want to look at what the amplitude is. Now, I put a -2, but the amplitude here is still 2. We know that our period is controlled by this coefficient in front, and our little b here is pi. That tells me between 0 and 2 pi, or 0 and about 6.28, we are going to see 3.14 cycles. So we have 2 pi divided by b, so we have a period of 2. We will have critical points in a cosine function, just like we did with sine, every 1/4 of the period. So when I scale my graph, I can see I have to go all the way up to 4. I'm going to definitely scale my graph by halves, because that would be very convenient to see. actually that's 1, that's 2, that's 3, that's 4. I could have stretched it out a little bit more. I was going to make that be a half to begin with, and I thought I might run out of room. So there we are, scaled by halves. That's pretty evident. I wouldn't need to write that down. Now my amplitude is 2, so I will have this go up to 2, down to 2. If you want to stretch it out more, that's fine. You can label this scaling this by halves as well if you'd like. Now, a cosine function will start either at a high if this is a lead coefficient is positive. And since this is a negative coefficient, it's going to start down here. So sine functions will start in the middle. Cosine functions are going to start at a high or a low depending on what the sign of that coefficient is. Now I have critical points every half a unit. I know my graph should finish a cycle in 2 units. And I start at a low, go to a middle, go to a high, go to a middle. And I'm going to quick sketch that. There's 1 wave, but I have to go until 4. And I know I should have 2 waves shown because if a period is 2 and I'm going out to 4, naturally I would see 2 waves. So there's a picture of my graph. I can label that. So that was theta, and that axis is y. All right, let's flip the page. Now likewise, I have another graph here. We want to sketch this graph over an interval from 0 to 2 pi. We also want to look and see now I'm using x as my independent variable, my input variable. I can see that my amplitude is 3. My period, 2 pi divided by b, which is 2 pi divided by 2, is pi. So I know that I'm going to see 2 cycles between 0 and 2 pi. In this case, I will label my axis with pi's. I'll have critical points every 1/4 of the period, and I'm ready to scale. Now I can see that when I scale this graph, I'm going to scale by pi over 4s. I'm not going to label everything. 1, 2, 3, 4. There's pi. 1, 2, 3, 4. There's 2 pi. And I will put a little note out here. Scaled by pi over 4, just so if someone's looking at this, they don't have to end up trying to count the spaces. Okay, now amplitude is 3. And I can see this time my lead coefficient's positive, so cosine function is going to start at a high. Critical points are every pi over 4, so I'm going to go from a high to a middle to a low to a middle. Make sure you don't miss the middle. Sometimes people jump the gun and they go from high to low, and to a middle, to a low, to a middle, and back up to a high. And I know that I was supposed to see 2 waves between 0 and 2 pi because of that little b being 2. Now, the next one says to find all solutions to this where I have this graph equaling -2, and I said estimate from the graph above. And I can see I didn't do a very good job of putting those little units there. If this is 3, that -2 should have been about there. So if I put a little dotted line here, I can see there are a whole bunch of solutions. And I can see there's 1 there. And again, this is pi over 2 right here. So if I were going to estimate what these were, I probably would want some little decimal approximation. This guy's about 1.6 here. So, if I'm going to guesstimate what this is, and this value is then going to be about 0.8. So each pi over 4 is about a 0.8. So I could estimate what this solution is and say, maybe that's about 1.1. And I'm going to be off on these, but I could guesstimate here and say maybe that's about 2.2. And again, I made some guesstimates here just by looking at my graph that they look kind of like they're about at these spots if I go through and label these spots in terms of a decimal. Now, if we're going to do this with our calculator, we would definitely want our calculator in radian mode. So let's do a quick little review of this. So we're going to get our calculator in the radian mode. I'm in radian mode. Going to go to y equals and type in my equation of 3 cosine of 2x. I'm also going to have in for y -2, and I'm going to graph over the window and make my window go from, I'll go as high as maybe, I'll go as low as -4. Oops, I'm sorry, I'm on the x's. I want to go from 0 to 2 pi. And I'm going to scale my graphs by pi over 4s, just like my graph is scaled on my little grid that I drew up above. I'll let my y value go as low as -4, as high as +4, and I'll scale it by 1, so a graph. Now, I'm going to have some intersections, and I'm going to want to figure out where those intersection points. And notice this graph looks very much the same as what my graph is here. In any case, if I go to my second and calculate, recall that that's our way of determining the intersection. And it tells me first curve, yep, I want 3 cosine of 2x. Second curve, yep, that's what I want. And then I have to do a guess. So I got to move that cursor over to, and it's not going to automatically give me all these spots, but I get the first one is at an x value of 1.15. Now likewise, I can do second calculate, intersect, first curve, second curve, and do my guess, and get the next one as well at 1.99. And I can find all 4 of those spots. And in reality, out to 2 decimal places, or to the nearest hundredth of a radian, those are my solutions. Now, you should be thinking, why in the world would I ever want to find this? And we need to get to context type questions, and we're not quite ready for that yet. Now, I have the same thing for this one for you to solve this. And what you could do is turn the video off, and you could find these places and then double check. Okay, so I'm going to put my answer up, but you again could do this on your own and then double check. I put this in as y sub 1. I put this in as y sub 2. I graphed it from 0 to 2 pi, and I could see it was going to be only one cycle that I was going to be seeing because of that coefficient there being a 1. These are not right at a spot I can read directly off of my graph, so I did have to go through the process of finding what these intersection values were, but I could estimate it from my graph. So we do need to be adept at being able to use our calculator, and we will also learn how to algebraically solve this coming up soon. Now you're ready to practice.